Hi, thanks for attending my talk at Node Week. My name's Colin Ihrig. I am a member of the Node CTC and TSC. Um, I currently work at Nearform, where they pay me to basically get to play with Node all day, every day. So the purpose of today's talk is to kind of cover the major happenings around Node in recent weeks and months, kind of let you know what to expect moving forward. Uh, the Node issue tracker is pretty chaotic, so unless you're really dedicated to paying attention to it, it's easy to lose track of what's going on. So the purpose of this talk is to give you sort of a high-level summary. So I think a really good place to start is with Node's release schedule, also known as the long-term support or LTS schedule. In 2015, when when IOJS and Node kind of merged back together, Node created a long-term support plan to address increasing enterprise use. One of the issues that people had with IOJS is that it seemed like things were moving too fast and things were kind of breaking regularly. For enterprise adopters, this is kind of a showstopper. They need a support plan that they can kind of rely on years out, that's very well defined. So the people at Node Core talked about this for a number of weeks, and this is the plan that they came back with. The goal of the plan is to balance a high-speed development and release cycle of IOJS with the stability that the enterprise requires. So twice per calendar year, in April and October, a new Semver major release is cut from master. On the graph here, you can see April 2017, October 2017, etc., where new major releases are cut. So, for example, in October of 2017, we're going to have Node 9 be released as the current branch. So the releases that come out in April are even numbered, and the releases that come out in October are odd numbered. This was not really the intention to follow the odd even versioning scheme that Joyent Node followed prior to the convergence. It just kind of worked out that way. So this year, version 8 will be is scheduled to be released later this month in April, while version 9 will be cut in October. So for every major release, it becomes the quote-unquote current release line for 6 months. Prior to Node 6, if you see any old release nodes, current was named stable, so you can substitute stable and current. The name stable was actually changed to current because it had some connotations of unstable releases. Even the releases that are only supported for 8 to 9 months are still pretty stable and safe to use. So version 7, which was released in October of 2016, is presently the current release. Version 8 will be released and become current later this month, at which point Node 7 will go into a maintenance period. So that's kind of the pattern that all odd numbered releases follow, is to be current for 6 months and then 2 months of maintenance, at which point they only receive critical patches and security updates. At the end of the maintenance period, it reaches its end of life and are no longer supported. So Node 7 is scheduled to be end of life by the end of July. If you're currently using Node 7, it might be something for you to think about now. Generally, people who are using the odd-numbered releases have a lot more flexibility and are able to update more frequently, but still something that you should be keeping in mind. Now, even-numbered releases are a completely different animal. After the 6-month current cycle, even-numbered releases go into something called active LTS. That is a period where they are considered very stable and kind of the recommended release that enterprises should be using. Active LTS lasts for 18 months. During LTS, there will be bug fixes, security updates, documentation updates, and if particular new features are deemed very, very useful, then they may be backported, but most new features are not. It is possible, for example, with a security update, that a LTS release would get a breaking change. In that case, we can't really bump the major version of the release. So what we do is we take Semver major patches as Semver minor and bump the second number. So before a commit can go back into an LTS branch, it has to be deemed stable. So it has to live in a current release line for at least 2 weeks. So it typically involves 1 or 2 releases before it can actually be backported to LTS. That's kind of a safeguard to prevent releases from landing in master and then going straight to LTS without any type of stability vetting. So once active LTS ends, a release line moves into maintenance mode for 12 months. Maintenance mode for LTS is the same as maintenance for non-LTS branches. It just lasts 12 months instead of 2. At the end of the maintenance, then that branch becomes becomes end of life. So version 6 is currently the active LTS release. As you can see on the graph, it's going to be the active LTS until April of 2018, at which point it'll go into maintenance mode. On April 1st of this year, version 4, which was the first LTS release under the LTS schedule, went into its maintenance mode. So Node 4 has about a year of life left. You can also notice that from October to April, there are 2 active LTS lines at any given time. So for example, if you look at October 2017 to April 2018, Node 6 is an active LTS, and Node 8 will also become active LTS. This overlap is intentional. It's there to give enterprise users that are kind of slow to transition a buffer period so that you can go from active LTS to active LTS with at no point having to rely on a maintenance mode branch if that's something that you don't want to use. Before I move on, I just wanted to say this chart was generated using the LTS module. You can download it from NPM and play with it if you want. So next I'd like to talk about node usage by version. So every month, Lori Voss from NPM tweets #NodeStats and kind of gives an overview of the usage of the different node versions over time. It's interesting to get this data from NPM because they're kind of in a unique position of seeing what versions of Node are actually being run. The Node Foundation has download statistics, which give a good estimate, but NPM actually sees what's going on, at NPM install time. So, as you can see here, roughly 80 to 90% of users are on the currently supported versions of 4, 6, and 7. You can see the gold line that starts at about 4/1/2016 and then shoots up dramatically. That is version 6. It's currently the most heavily used branch at roughly 50% usage. That's actually exactly what we want. There you can also see that Node 4 is kind of trailing off, and that Node 7 is picking up a lot of usage. Now, you also see that Node 5 is still, fairly heavily used, and so are Nodes 0, 10, and 0.12. We really need to get these numbers down to 0%. All these branches are end of life. Node 0.10 is roughly 4 years old. It's got a version of OpenSSL in it that is no longer supported. So if you're currently using those, highly encourage you to move off of them. The jump to Node 4 isn't terrible. I would say if you're still on 0.10 or 0.12, to try to focus on Node 4. Once you get to Node 4, it's then easier to move up to something like 6. Ideally, everybody should be on 6, but 4 is still perfectly fine for the next year. So next, I'd like to talk a little bit about Node 8. So Node 8 is the upcoming release. It is currently scheduled for April 25th this month, but there is a chance that it could be pushed back due to some issues with what version of V8 will ship in Node 8. I'm going to talk about that a little bit later. Just know for now that we're currently scheduled for the end of April, could slip into May. Another thing to note is that starting with version 8, we decided to stop saying V4, V6, V8, etc. So we should drop the V and just say Node 8 or Node version 8, or call it by its LTS version if it has one. The reason for this is because people were getting really confused between Node V8 and V8, the JavaScript engine from Google. So there was a lot of discussion about what we should do about that confusion. Some people actually had the idea that we should skip Node 8 altogether just to avoid that confusion. It was kind of decided the simplest and least confusing way to go is to just drop the V. That said, Node 8 is scheduled to become an LTS line in October, and every LTS release line is named after a periodic table element. So Node 4 was the first LTS line. It was codenamed Argon. Node 6 was the second one. It was codenamed Boron. So Node 8 is going to take an element whose name starts with C. It's been, I don't think it's official yet, but it's been pretty much determined that element's going to be carbon. So you can call it Node 8, Node version 8, Node carbon, etc. This is going to be the first LTS version that has WebAssembly enabled in it. So that was something that came in V8 5.7, which is the current stable version that will definitely be included with Node 8, at least. It's also going to become the first LTS release that has async await without a flag. So people have been, very, very antsy waiting for async await to land without a flag. That finally happened in Node 7.6, but version 7 is not an LTS release. So if a release line being LTS is kind of a requirement at your company, then this is the first LTS release that will have that for you. As I said earlier, we're not sure exactly if the V8 version is going to be 5.7, 5.8, and what exactly the upgrade path is there. I'll cover that in more detail later. Node 8 is currently scheduled for an earlier than usual end of life on December 31st, 2019. Normally, this date would have been in April. So the reason for the shortened maintenance period is the version of OpenSSL that's going to ship with version 8 is actually going to be end of life at the end of 2019. So that means we're going to end of life Node 8 to prevent any security issues that will go unpatched in OpenSSL. So I'd like to talk a little bit about some of the features that we can expect in Node 8. One of the biggest is going to be improved language support. As I said, it's going to have things like async await. Node 8 is going to support roughly all of ES 2015 and 2016. So I took this image actually shows some of the headers from node.green, which is a great website you can go to see what versions of Node support which language features. So I took the headers and kind of combined them into a single image, and you can see that from just a couple years ago when a lot of people were running 0.10, there was roughly 6% ES 2015 support. With Node 8, we're up to about 99% of that. So there's still some progress being made on ES 2017, but that's to be expected. I mean, it's currently only 2017 after all. Notably missing from the support tables are ES modules. There's been a lot of discussions between TC39, the body that is in charge of JavaScript as a language, and the Node team about how ES modules don't necessarily work very well with Node's CommonJS-based module system. So there's still a lot of discussions being had, a lot of work being put in to decide what's going to happen there. So don't expect ES modules in Node anytime in the very immediate future. Luckily, Node has close to 500,000 modules on NPM that they can lean on without ES modules. I would recommend not transpiling ES modules using Babel. The semantics that you get with spec ES modules and the semantics that you get with Babel transpiled ES modules are not 100% compatible. I think at this point you're better off, if you're doing Node development, to just stick with Node's module system. And another thing I'd like to caution you about is be very careful when you're adopting new language features. So what normally happens is developers are very excited that their new favorite language feature has finally gone stable, something like async await. And these things, when they first make it into the JavaScript runtimes like V8, are not usually as optimized as features that have been around for a while. And so what happens is there could be bugs or something else, and you get all of a sudden a slowdown that you weren't expecting. An example of this that actually happened in Node 7 was we started using symbol.hasInstance, and that automatically slowed down all instance of operations by up to 100 times, even if it wasn't related to the direct usage of symbol.hasInstance. It was kind of a global effect that slowed down a lot of things. So we got burned by that. I want you to not get burned by using new language features. When you introduce new language features into performance critical code, please make sure that you're benchmarking. The issue with instance of has been resolved, so that's no longer a concern. Another improvement is in Node's documentation. This may not sound, very important, but whenever you're the person trying to write the application and need to figure out why something's not working or what you need to do, the documentation, is very important. So the documentation is always being improved. That includes the code samples, the descriptions of the methods, and the options. We've recently started becoming better at specifying the data types that go into return values and function arguments, for example. One of the biggest changes is that individual entries in the documentation now have their own change logs. So what we were doing before is specifying when a new method or property was added, we would have a little note that said added in version whatever. That wasn't really enough though, because it didn't capture things like the addition of a new function parameter or slight changes to the behavior of the function. So what we did was added a changelog to every entry. So now you can see, for example, with child process.fork, it was added in Node 0.5, and then starting in Node 6.4, the stdio option is now supported. That's something that would have been hard to capture before and might have required a note in the documentation itself. Now we have these change logs. They're collapsed by default so that they don't clutter up the page. And if you want to see what's changed and when, you just expand the little history button. Along with the documentation are improved tests. We currently have over 1,400 tests run on the CI for every commit. The number of tests in core has increased by several hundred over the last few years. I personally remember when it was down around 1,000. So that's significantly more testing going on with the code. The tests have improved in both quantity and quality. There's been a lot of work to go through old tests and kind of bring them up to modern coding standards and make them a lot stricter. So the tests are now thorough. They have very tightly defined behavior. That includes things like making all the comparisons strict comparisons, so no double equals, we use triple equals. Tracking what events are emitted, verifying that functions are called, and checking that error messages haven't changed. Error messages have actually been a pain point when we would change them in core. We have people in the ecosystem that are relying on specific error messages, and when those change, it actually breaks their code. So like I said, every commit runs through Node's custom continuous integration setup. We have CI running with Jenkins on a number of donated machines. The machines are maintained and monitored by Node's build working group, and we test from everything from macOS, Windows, AIX, ARM, a number of flavors of Linux. The CI is actually public to view, so anyone can actually take a look at what all platforms are covered. I think we've recently added a supported platforms document to the core repo as well. Another new feature is nightly code coverage reports. So we never really had a good handle on code coverage before. People would make a lot of changes and not cover their new code. Now we actually get a daily report. So the image shown here is kind of a screenshot for the past few days, and it has a link to the head of the master branch, so you can click on that and actually view the code at that point in time on GitHub. And then there's links to the JS coverage and the C++ coverage reports, so you can go in and you can see what lines inside the code are covered, what branches are covered, what's missing coverage, etc. As you can see here, we don't strictly enforce coverage yet. A couple days ago, JS coverage was at 91%. It dropped down into 90%. But between JS and C++ coverage, we generally hover around 90%, which I heard a number was up from about 5% from a year ago, I think. So that's showing a lot of improvement in that area. A lot of releases nowadays are mostly made up of docked and test improvements. The reason for this is Node is trying to make it easy for casual contributors to come in and get associated with the project, and docs and tests kind of make for a good entry point there, because you can change some stuff without breaking or causing regressions on people's actual production setups. So the next thing I want to talk about is safe buffers, or safer buffers. So the little screenshot here is from an issue that was opened in January of 2016. As you can see, it received over 200 comments. This is just one of the many threads on buffers that received over 100 comments. Basically what happened was there was a remote memory disclosure in the popular WS WebSockets module in January of 2016. The issue stems from the fact that the buffer constructor accepts a number or a string, and the behavior, depending on what type of the parameter is passed in, is very different. If you pass in the string 1000, you're going to get a buffer that contains the string 1000. If you pass in the number 1000, you're going to get essentially a malloc of uninitialized memory. And so the way the remote memory disclosure worked was there was not adequate type checking going on with the buffer constructor, and so it was possible to just keep asking for unallocated memory or uninitialized memory from the WS module, and you could end up seeing things like certificates or passwords, anything that was stored in memory and not garbage collected or cleaned up. So to deal with this, Node Core introduced buffer.from, buffer.alloc, and buffer.alloc unsafe. Buffer.from lets you handle things like passing in the string. Buffer.alloc and alloc unsafe are for passing in the number version of the constructor. alloc will actually initialize your memory for you, make sure that there's no garbage left in there from old values. Alloc unsafe is the legacy behavior. It's what you use if you're absolutely confident you know what you're doing and you don't necessarily have to worry about initializing the memory. So we came up with these new methods and thought, everything will be great. We can go ahead and deprecate the buffer constructor. So we tried doing that in Node 6, and it went spectacularly badly. People complained that all of a sudden there were warnings in their CI output that weren't there before and were causing their CI to fail. People who depended on these modules were all of a sudden getting these messages printed to their standard error and had no way of changing it because it was coming from a module they depended on. People who were maintaining these modules said, this module's done, I don't want to go back and have to change it at all. So buffer is one of the most widely used and heavily dependent upon APIs in Node, and it was kind of determined then that we weren't going to be able to just deprecate this, at least not right now. So there were a lot of issues and pull requests, hundreds of comments were made, a lot of heated arguments that happened on GitHub and spilled over onto places like Twitter. Finally, on March 29th, 2017, the CTC sat down and voted on things. We don't typically vote on things. We generally consider it better if we can just everyone comes to an agreement. That's part of the consensus-seeking model. In this case, there was no agreements to be had. People had very strong opinions on both sides of what we should do. So the CTC voted on it. We decided we are not going to deprecate the buffer constructor, at least not at this point in time. And in Node 8, we will start zero filling buffers by default. So if you're using new buffer and don't want to update, your code will continue to work perfectly fine. You may see a performance hit of up to 70%. If you need the extra performance and you're willing to update your code, you can go ahead and use buffer.alloc unsafe. Otherwise, you should take the zero fill buffer from Node 8 or update to buffer.from buffer.alloc. That is kind of a summary of the past almost year and a half in buffer drama. On a more positive note, we now have the V8 inspector. So the V8 inspector gives DevTools integration with Node.js out of the box. Historically, debugging tools for Node were not great. The Node inspector was created a number of years ago that allowed Node to work with Chrome's DevTools, and that was awesome. As a third-party tool, sometimes the Node inspector would lag behind what was going on with Chrome and Node and everything else. So there were periods where that would need to be updated. So in the past year or two, the JavaScript-related pieces of DevTools were pulled out of Blink and put into V8 directly. So as they became a part of V8, they automatically became bundled with Node, which was great. So this means that now, out of the box, Node has access to things like step debugging, CPU profiling, heap snapshots, and more. Basically everything that's supported in DevTools. So you might be wondering, how do I use the V8 inspector? Well, all you have to do is pass -- inspect to Node whenever you run your application, and that will run the inspector. You may want to actually run it with a breakpoint set at the first statement of your application so that you can connect to DevTools, etc. In that case, you would use -- inspect -brk. So when the inspector is enabled, you'll see some output printed to the console. It'll contain a DevTools URL that you can copy from the console and paste into the Chrome address bar, and that will launch DevTools and bring up your code and everything like that. So this URL contains a long, unique identifier. This was not originally the case. This was added for security purposes. This prevents strangers from connecting remotely to your to your servers. Because DevTools does support remote debugging, it was kind of figured out that, hey, any random person who knows the predefined URL can just connect to your box. So that was why the unique ID was added. This kind of frustrated some people because they could no longer just have one debugger session open and constantly, reconnect to Node. You would have to copy and paste a separate URL every single time. There was also some discussions about how fair it was to other vendors to print out a Chrome-specific URL to the console. For example, Microsoft is integrating with the V8 Inspector in their VS Code project and other things. And it doesn't really make sense for their use case to have Chrome DevTools URLs printed out. So there's been some discussion about potentially removing that URL. It hasn't really gone anywhere thus far. And as I recall, there was also an issue for Windows users where copying and pasting from the Windows terminal, because the URLs often span an entire line, that copying and pasting didn't work great for them. So for that purpose, I created the Node.js V8 Inspector Chrome extension. There's a little screenshot shown here. It supports things like one-click debugging. So you can click on it and it will automatically connect to your saved port, saved host, etc. So that saves you from having to do the copy and paste. The way it works is Node exposes an HTTP endpoint that tells you where the debugger is running, and then you can connect to that long URL containing the unique ID over a WebSockets connection. So basically this Chrome extension just automates that part of it for you. It also supports automatic reconnection. So if you restart Node, it can detect that and automatically reconnect to Node to find out what the new URL is, and then reconnect DevTools for you. Along with the V8 Inspector, we're also going to be removing the old command line debugger. So if you've used Node --debug in the past, then you're going to have to migrate off of that. It's going to be going away. It depends on a legacy debug protocol that's being removed in V8 5.8. The debugging protocol has actually been deprecated for years. I'm pretty sure the only reason that it's been kept around was for Node to keep using it because people were depending on it. So it's finally going away in V8 5.8, and it's been decided that Node 8 is just going to remove it so that we can, cut the cord and be done with it, not have to worry about it in the middle of a release line. It's going to go away. The alternative now is to use Node Inspect, which is now bundled with Node as a replacement. So instead of doing Node --debug, whatever your script name is, the new usage is going to be Node debug script.js. Again, that's only if you're using the command line debugger. I would highly recommend using the V8 Inspector myself, but that's my personal preference. So another area where Node has been improving is in something called VM neutrality. So up to this point in history, Node has really only ever run on top of V8. And a lot of other companies have perfectly good JavaScript engines. So the question has been asked, should Node support other runtimes? At first, it seems like a very cool idea to just be able to plug Node into any other JavaScript runtime and have it work. It's actually a non-trivial thing to do because there are considerations to be made. Like currently, we have a version of V8 that ships or is kept inside of the Node core GitHub repo. If we start supporting other VMs, would we start including all of those inside the repo too? And then we have to ask the question of what does it mean to be Node? So right now we know what Node is because it runs on V8. We have a test suite, and that's that. we would have to define what level of compatibility has to be maintained with the baseline in order to still be determined to be Node. So in early March, there was a VM neutrality summit held up in Microsoft. People from a number of companies like Microsoft, obviously, Google, Nearform, NodeSource came together and talked about what it means to be Node. And it's still kind of being hashed out what a conformance test would look like for Node. I would think that minimally you should have to pass Node's test suite on the platforms that you're planning to have support for. And a lot of this discussion came around because Chakra Core was actually able to get Node running on Chakra. So if you're not familiar with it, Chakra Core is the engine that powers Microsoft's Edge browser, and it's kind of their equivalent of V8. They were able to put together a pull request that showed Node running on Chakra. It did not get merged into the main repo. There was still some work that needed to be done. It was, at that point in time, it was only running on Windows. That's no longer the case. It now runs on multiple operating systems. There were tests that were failing. It wasn't really ready to come into the main repo, and the amount of overhead that it would bring in with it. So a separate repository inside the Node.js GitHub org was created for it. It's still there today. You can go look at Node Chakra Core. It gets updated and synced with master pretty frequently. The way it works is the Chakra team implemented a shim layer between V8's APIs that Node.js calls out to in its C++ bindings. The shim layer sits between that and Chakra, so Node still thinks that it's talking to V8 when really it's just using the same interface but talking to Chakra under the hood. So like I said, it's not currently an officially supported release of Node, but it's there and it's a pretty cool project. And that kind of led to something that's even more cool, known as the Node.js API, or NAPI. NAPI is able to provide ABI stability across Node versions and different runtimes. So the way things currently work is when the C++ API changes, native add-ons need to be rewritten. This used to be a major problem because V8 C++ API used to change a lot and very quickly. And there were numbers calculated that the breakage used to affect roughly 30% of the NPM ecosystem every time one of these breaks occurred. That number has probably gone up since that time. That number is a couple years old. So this frequent breakage led to the creation of NAN, which stands for Native Abstractions for Node.js, which provides a stable native API across versions. One of the problems is, though, that NAN it can't really predict the future, so it can kind of paper over the differences from Node 0.10 and forward, but it doesn't really know what changes are going to come next. And so what happens is the application binary interface changes sometimes, and in Node Core we deal with that by bumping a constant called the Node module version. So when this happens, native add-ons that have been compiled with one version of Node need to be recompiled, even if they are using NAN. So you may have seen errors before when you upgrade your version of Node saying, this add-on was compiled for version X and you're on version Y or something like that. So what NAPI does is it takes the idea of NAN one step further. It provides a stable API and ABI for module authors. It builds on the same idea of the shim layer used in Node Chakra Core. So this means that when something is compiled for NAPI, the same module can work across versions of Node. So it could work. The same module could work for Node 4, Node 6, Node 8, etc., as long as NAPI is able to handle that. The same module can also be used across multiple VMs. So the same module could be working for Node 4, 6, and 8 on V8, but also work for Node Chakra Core. So that's an extremely powerful abstraction. The way NAPI works is it provides a number of simple C-style APIs and then an optional C++ wrapper layer on top of those APIs for kind of increased usability. The C++ wrapper is optional to use. The NAPI implementation was reviewed by the V8 and Chakra Core teams. An implementation currently exists for Node 8, aka the master branch, Node 6, and Node Chakra. So they would have to do some work to backport it, further than 6. What the NAPI team did was port a number of popular native modules to NAPI and then do some benchmarking and testing on them. They were able to cover a large portion of the V8 APIs. There are some corner cases that were not very heavily used and not really recommended to be used. So the plan is to not necessarily cover those. And then they observed a performance hit of roughly 0 to 10%, depending on the module. So modules that go back and forth across the C JavaScript boundary a lot, they were kind of determined to be chatty, as in they chat with the C++ layer a lot. Those ones saw the biggest hit because they were going through NAPI the most. And so a pull request was recently opened and merged into master. So NAPI is there. It's in the code base. It's being updated and improved and will ship as an experimental feature in Node 8. And the last bullet point on this slide is a link to the NAPI demo from Node Interactive North America in 2016. It actually shows an example where the same native module is being used across Chakra Core and different versions of Node. So if you haven't seen that before, you should go check it out. And then Node 8 is also going to have some other miscellaneous breaking changes. The full change log is shown in the link if you click on the link in the bottom of these slides, which I'll send out a link to later. Since Node has moved over to Semver, breaking change, major release breaking changes, aren't that interesting anymore, because basically bugs get fixed in patch releases and all the new features come out in Semver minor releases. So the biggest breaking changes in Node 8 are probably going to be improved validation and errors. So error message changes, as I mentioned earlier, are considered Semver major, even though they're not really breaking very many people. And then improved validation. So JavaScript is not strongly typed. So we've added a lot of checking in Node to make sure that we're getting the expected data types that the APIs are expecting before the data is passed through and causes some unexpected crashes. But those lead to changes in the error messages, so they become breaking changes. One big breaking change in the code itself is outgoing message.prototype._headers has been deprecated. So it's still there. It won't break your code, but you will get a deprecation message now. It's planned to go away one day. The reason it's such an important breaking change is that I believe Express is or was relying on it. It's been replaced with a public API, so instead of having to use an underscore property, there's actually a public API there that you can use now. Also, the REPL's magic mode has been deprecated. So magic mode was important back whenever strict mode and ES6 features weren't necessarily the main thing that people used. And the REPL, I think, would default to sloppy mode. Magic mode would actually try to execute something in strict mode, and if that didn't work, then it would fall back and try to execute it again in sloppy mode. We no longer really need those semantics, so the magic mode is being deprecated completely. And another big breaking change is in util.inspect. So some things are going to be printed out differently. Deeply nested arrays are printed as arrays now. External objects are printed as external instead of just what looks like an empty object literal. Symbols are now shown by default, whereas they were hidden before. Just other small tweaks to it. Because util.inspect is used so heavily throughout the Node ecosystem, it's likely to break some things that are expecting certain output. But again, it's not really a huge functional change. So those are some of the big breaking changes that are going into Node 8, but I don't think it's anything that people really need to worry too much about. So now I want to circle back to what's going on with V8, because Node has a number of dependencies, but V8 probably has the most influence on the path that Node's going to take. Out of all of Node's dependencies, V8 changes the most and changes the fastest, so it's kind of prevents the most problems for Node. So one thing that a good thing is that V8 has been seeing improved performance. So this graph shows improvements in async await and promises from V8 5.6 to 5.7, which is the minimal version of V8 that Node 8 will ship with. Like I said earlier, many new language features are not highly optimized when they're initially released. The developers are excited to use them and then see unexpected slowdowns. So the V8 project has been focusing on improving performance of new language features. They were able to lean on the 6-speed project that was created by Kevin Decker to compare the performance of new language features with their ES5 and transpiled equivalents. The V8 team forked 6-speed and began using it for their own purposes to improve performance. So V8 5.7 is the current stable release of V8, and it has shown approximately quadruple the performance for async await and double the performance for promises. This graph was taken from the V8 blog. They said that these tests involved using micro benchmarks, which generally isn't the best way to benchmark, but it's something. And then other things of note are the spread operator, destructuring, and generators are roughly as fast as their ES5 equivalents in V8 5.7. So this chart, also taken from the V8 blog, shows the performance of ES 2015 features relative to ES5. There's been an overall ES 2015 performance improvement of over 47%. This actually shows from V8 5.4 up to V8 5.8. 5.8 is the release that's scheduled to go stable later this month. So you can see that clear progress is being made on improving ES 2015 features. So this is all great, but we still have the question of how is Node going to track V8 releases? V8 moves very fast. They have a 6-week release schedule. They're developed by Google, primarily for Google, although the relationship with the V8 team and the Node team has improved a lot in recent years. There didn't used to be a lot of talking. Now there's, we've actually been on calls with them. We have people from Google and the Node CTC, so that relationship has actually gotten really good. But we still have the problem that they're targeting Chrome, which is evergreen, and they're able to abandon their old versions. Node is not evergreen, clearly. We still have people running unsupported versions. So we had to take this into account when we created the LTS schedule, and we did take this into account. But we still have a problem that I'm about to talk about, and that is a new compiler pipeline. So in V8 5.9, so not the one that will go stable later this month, but the one that will go stable in a couple of months, they're going to turn on a new compiler pipeline called Ignition and Turbofan. So that is currently in V8, but it's not the enabled option by default. Currently, they're using their old optimizing compiler called Crankshaft. What the thing that they're going to be switching to, Ignition, is V8's new JavaScript interpreter. Using Ignition, V8 compiles JavaScript functions to bytecode that is 25 to 50% of the current implementation's machine code size. And Turbofan is V8's next generation optimizing compiler, so it's actually going to replace Crankshaft. The problem is a lot of existing code, including in Node core itself, is highly optimized for Crankshaft. And historically, tuning code to Crankshaft strengths can mean performance differences of up to 100 times. So when we switch from Crankshaft to Turbofan, the performance profile is expected to change dramatically. So things that once worked well on Crankshaft may not work so well anymore. And Turbofan is expected to optimize new language features much better than Crankshaft currently does. Switching to Turbofan also means no more optimization killers. So in Crankshaft, using certain language features prevented the entire function that contained those language features from being optimized. So that includes language features like width that people don't use so much, but also includes things like try catch and try finally, which is used to handle synchronous errors. And with the introduction of async await and the way those work with try catch, it's kind of important that we be able to optimize async await as well as try catch for their error handling. And I'm happy to say that those things are now fully optimizable in the new pipeline. It doesn't mean that old features that were optimization killers before will now all of a sudden be highly optimized and fast, but they won't disable optimizations for your entire function, which is what would happen before. So basically, a lot of code is going to need to be revisited that was optimized for Crankshaft. The Node CTC and the V8 team had a call in late March. One of the topics that came up was the new compiler pipeline, and the V8 team expressed concern over some certain things in Node core that are highly tuned to Crankshaft. For example, Node's event emitter implementation is very highly specific to Crankshaft. That'll probably see some slowdown. Luckily, the V8 team expressed some interest in not only helping us identify these features, but also sending patches to Node core to fix these performance regressions as they're discovered. So there's ongoing work to determine where the pain points are going to be when we switch compiler pipelines. Turbofan is going to be for the foreseeable future, going to be the new pipeline. So once we get off of Crankshaft and completely over to Turbofan, life should be good. But performance regressions are likely to happen once V8.5.9 lands in Node. And it's still being determined if this is going to happen in Node 8 or possibly pushed to Node 9. That slide is completely formatted wrong. So some of the LTS options, we pretty much have 3 options moving forward on what we're going to do. The first option is to stick with the LTS schedule as planned. That would mean that Node 8 will ship with either V8.5.7 or 5.8. The problem is that once V8.5.9 lands, that's going to create a huge delta between Node 8 and everything in front of it. It's going to make backporting changes incredibly difficult because there'll be a lot of conflicts. It would also mean that as all changes are backported, they're going to have to be profiled for performance, because when something lands on a newer version of Node, it will have a completely different performance profile due to Turbofan than it would when it's backported to Node 8. So that is the first option. None of these are really great options, but that possibly is the worst of the options in my opinion. Next is to have a modified V8 5.8 with an ABI that is kind of tweaked to be forward compatible up to 5.9. So this would mean that we ship V8.5.8. It's slightly modified at the API layer so that there'll be a path forward for Node 8 in a Semver minor release to update to V8.5.9. V8.5.9 is scheduled to go stable in early June. So if we were able to stick to this plan, then we would have crankshaft and turbofan and ignition in Node 8 in June or July. And that's still several months before Node 8 transitions to LTS in October. So this would make backporting changes significantly easier. However, they're expecting that there could be a large amount of churn in V8 between 5.9 and 6.0. This would be because in 5.9 they're going to turn on the new compiler pipeline. People will probably find issues, report bugs, etc. And so a lot of things will need to be fixed and updated. If this happens, then that would mean that even being on 5.9 could potentially not be enough, which leads to the third option of delaying the release of Node 8 for 3 to 4 weeks. So that would put us into May, I believe, and shipping with a version of V8 that is forward compatible to 6.0. So the biggest downside to this is that it would mean delaying release, but it would give us a path all the way up to Node or to V8 6.0, which is not even scheduled to go stable until August, which means that for a long portion of Node 8's lifetime as an LTS release, it'll have options as far as backporting changes from V8, being more thoroughly tested, etc. So like I said before, none of these are really great options, but between the excitement around the V8 version and the early end of life because of OpenSSL, Node 8 is proving to be a pretty interesting release. And then there are just some other things going on in the Node.js GitHub org that I wanted to direct you to. The first is Node.js/help. This is kind of the repo where you should go if you need support. A lot of people open questions on the Node.js node core issue tracker. This is that issue tracker is for feature requests and bugs. If you just have general support questions, we recommend you go to Node.js/help and ask them there. The second repo I want to point you to is Node.js/llnode. llnode is a C++ plugin for LLDB, which is a debugger. It provides mixed C++ and JavaScript stack traces and inspections of their values. It's extremely useful for postmortem debugging using core files. And it also means that you no longer need a SmartOS box and MDB for postmortem debugging, although this is not quite as powerful yet. It's still fairly new, but I like it a lot. Also, Node Report is a pretty new module that is maintained by the Node Foundation to create human-readable diagnostic summaries that can be written to file. Those summaries include things such as CPU utilization, memory usage, resource limits, environment variables, system information, garbage collector statistics, things like that, so that whenever you have a crash, you can get a very, very good dump of what was going on in your environment at the time. That can be triggered programmatically, via exception, via signal. There's different ways to use it. And the final repo I wanted to point you to was the HTTP2 repo. I'm not going to talk a lot about that. If you watched James Snell's Node Week talk, it was completely focused on the topic of HTTP2. Basically, that repo contains the implementation of HTTP2 that's intended to go into Node Core. A couple of upcoming events if you're interested in attending. The Node.js Collaborator Summit is going to happen May 4th and 5th in Berlin. It's going to be the 2 days before JSConf EU. The Collaborator Summit is going to be held in the co.up co-working space. Node Summit is going to happen July 26th and 27th in San Francisco. That's going to be at the Mission Bay Conference Center, and it's going to come with another VM Neutrality Summit, So that should be interesting since NAPI is now in Node Core. Node Interactive is going to be October 4th through the 6th in Vancouver at the Vancouver Convention Center. This year, we decided instead of having multiple Node Interactive events, there's just going to be the one. So if you have to pick one thing to go to, it's kind of recommended that that be it. And then NodeConf EU currently has their call for proposals open. It's going to happen November 5th through the 9th in Ireland at the Lyrith Estate. Nearform is going to be sponsoring that again. So if you can't make it to any of the North America events, recommend you go into NodeConf EU. And that's the end. You can reach out to me at CJIHRIG on Twitter, GitHub, pretty much all the things. Thanks.